Hi, this is Mr. Weston. Today we're doing a Khan Academy tutorial on line and angle proofs. This was requested by Shamsid Sunan, so thank you for requesting the video. You can always request your own video by leaving a comment on any of the videos and telling me what you need. So for this Khan Academy, we have AB is parallel to DE. So we're talking about parallel lines and transversals here. But this first question, we really don't need to know that much about parallel lines and transversals. It's more about like a puzzle, and I'm going to explain as we go along. So it says complete the proof that when a transversal crosses parallel lines, corresponding angles are congruent. Okay, so let me show you what corresponding angles are first. Corresponding angles in this picture are Z and W. I can't zoom in on this, but I can highlight it. So Z and W are here and here. I like to think of corresponding angles as being in the same spot of like the intersection. So if you think of roads here and the intersection, so here's the intersection of those roads. They're both in like what I would call the southwest corner of that intersection. That's corresponding angles, when both of those angles are in the same spot of the intersection, okay? So it says this proof uses the following theorem. When a transversal crosses parallel lines, alternate interior angles are congruent. Real quick on what alternate interior angles are. So there's a natural space created when we have parallel lines in a transversal. So we have what we would call the exterior space. This is on the outside between those parallel lines. And then we have the interior space, and that's inside between those two parallel lines. Now we have the transversal coming through. There's our transversal. And we have, if the angles are on the same side, that means they would be on this same side of the transversal. But if on alternate, so we'd have alternate, they would be on opposite sides of that transversal. Just to give you some of the lingo. So when it says alternate interior angles, what we're really talking about here, let me erase all this. What we're talking about is, we're talking about this interior space. Okay, so this interior space. And then we're talking about on opposite sides of it. So here and here would be alternate interior angles. The angles they have here for us already are this X and Y. Okay, those are labeled alternate interior angles in this problem. So let's go ahead and proceed. We actually don't need to know that much about that to do this problem, but let's go ahead and get started. So we have AC is parallel to DF. That's given. The next clue it gives us is W. Measure of angle W and angle X equals 180. So we're looking here at the picture. You can see they're right next to each other. Again, lots of highlighting here, but I hope this is helpful. So these two angles are next to each other, and they're both on the same line, so they need to add up to 180, okay? They're supplementary. Anytime they share like a side like that, they're going to be equal to 180. And Y and Z is the same thing. So if you look at Y and Z, it's slightly different setup, but the same principle. They both share a line here. They're on the same side, and that needs to add up to 180 also. Now, here's where we first have to do a proof. So when you make a decision here, W and X added together equals, and it says substitution 2 and 3. What it's talking about is the second and third step. So here we have 2 and 3. And you can see if they're both equal to 180, that means we could set them equal to each other. So here's the yellow one. We can now set the green one equal to it. Let me go ahead and write that in green. So we know that measure of W plus X is going to be equal to the measure of Y plus the measure of, I should put an angle there. Measure of angle Y. I'll just put angle Y just so I don't have to write the M. But really it's the measure. So we have measure of, I can't write it. There we go. Measure of Y plus measure of Z is going to be equal to W plus X because they're both equal to 180. Okay, so I need to go ahead and put Y plus Z here. Okay, so that's that step. Now we're moving on. So we have, this is a completely different thing, and you can see that we're not using prior information on this from the previous proof because it says alternate interior angles of parallel lines are congruent. That was from the statement it gives us. So it's telling us that measure of X and Y are equal. That's what in the first things I said. That blue one and that purple one are equal. Okay, so we're going to use that for our next puzzle piece. So we say W plus X equals. Okay, and it's saying substitute 4 and 5. So we already know for 4 that W plus X equals Y plus Z. And we can substitute x for y. So it tells us, let me erase all this again. It tells us that we're going to use 4 and 5, and we can replace anywhere we see a y with this x. Okay, so what we're going to do here is we're essentially just going to cross this off, and we're going to write measure of angle x instead. So we can say that measure, using this, measure of w plus x is going to be equal to measure of x plus measure of angle z. And that's right from this one right there. Okay, so we need to complete that statement. Let's go ahead and do that. Measure of x plus z, because we use substitution from the 4th and 5th step. And then we subtract x from both sides. Let's say I didn't know that. I didn't know if it was x or z or what. Let's say I got confused. I can look at this last step, step 7, and say I have to subtract x from both sides. So if I choose like measure of y plus measure of z, well, equal to this one, well, I know I don't have x on both sides, so I need to choose one with x. And then I can kind of look back at previous steps like this one and realize, okay, I needed to substitute x for y, not y for x, because this last step's telling me I need to subtract x from both sides. So I should be good here. Let's check it, and let's move on. All right, here we go. This one looks involved. So we have TV parallel to WX. Okay, just as a refresher, here's TV, here's WX. Okay, those two lines. And they're parallel. So we have some other things going on. WU perpendicular to TV. Okay, WU is right here. And then VY perpendicular to WX. Okay. And then those, it's just saying that U and Y are on those lines, those green lines. So Cody noticed that, let's see here, triangle, that's what that triangle means. Triangle UWV is congruent to YVW using the hypotenuse leg congruency postulate. Okay, so quick recap of hypotenuse leg. For hypotenuse leg, you have to have a 90-degree angle, and both of these are because it said it was perpendicular. And then they have to have a hypotenuse that's congruent. So they share that hypotenuse, so it's going to be congruent to both those triangles. And the two triangles here, you can kind of see there's one. I'm going to do this one dotted. We'll call that triangle. This one's UWV. And then we have this other triangle here. This one will make solid line, and that's triangle YVW. Okay, those two are congruent to each other because you can see the green and the green match up, the blue and the blue match up, and then the yellow is shared. Okay, so hypotenuse leg is what we're going to be talking about here. So let's see. What theorem can Cody prove using these congruent triangles? When a transversal crosses parallel lines, alternate interior angles are congruent. Well, first off, that's a true statement if you know about the theorems for transversals. Okay, but let's just go back to this problem and see if it is true. Okay, so I have a lot going on here. Let me erase a little bit. Alternate interior angles. Okay, we talked about the interior space. Okay, we already know those two triangles are congruent. Okay, so if we know those two triangles are congruent, alternate interior space is in here, this area. Sorry, that was a little sloppy. So this area is the interior space, and then alternate would be one on this side and one on this side. Now, would that be congruent? And you can tell if we were to reorient this triangle, okay, and there's its right angle, and then orient this triangle and have it come up, you can see those angles are both in the same spot. So that is true. Okay, so this one is true. Let's just take a look at the second choices. When a transversal crosses parallel lines, same side interior angles are congruent. That is not true. So if we're looking back up here, same side angles would be, for example, this one and this one. You can tell just by looking that they're not, and it's not true, okay? It's not true that same side interior angles are congruent with parallel lines and transversals. That one's out. Angles that form a linear pair are supplementary. That is true, but they're not. For this problem, that doesn't really help us. The only angles that would help us for this proof would be, like, for example, this angle right here, this new angle, and then this one. So that's not at all in the proof because the triangles don't have both those angles present. So that one, it's true, but it's not. It doesn't apply to this problem. And then vertical angles are congruent. That is also true, but again, we don't have vertical angles in this problem. Okay, so we don't have The only vertical angles we have are here and here, which is true, but it's not part of either one of those triangles, so that one we can't prove. Okay, this one's actually pretty tough. Some of them might have just straight up bad choices, like letter B was a bad choice, but that one was actually a little bit tougher. Line L is perpendicular bisector of segment WY. Z is a point on L. Okay, so it's giving us a lot of information in this diagram. Maybe I'll talk about that in a little bit. Nicholas noticed that triangle WXZ and triangle YXZ are congruent based on the side angle side congruency postulate. Let's talk about that real fast. Okay, so we have these two triangles here. I'll make them different colors. So side angle side, that means that they have a same side, and it's right there. It's saying that that side is congruent. Then we have an angle. So if it's a perpendicular bisector, that means they're both 90. So there's our angle. And then they share this side. This side is the exact same side for both. So that's its other side. So that's why side angle side works for this problem. Okay, so side angle side does work. Okay, I'm going to erase this now. If you want to go back and look at it, it's fine. Just rewind a little bit. But we're going to be using that information to see vertical angles are congruent. Well, again, there's no vertical angles here. The only vertical angles that are involved with those two, well, there's no vertical angles involved with those triangles, but there are vertical angles here. But again, it doesn't apply to these triangles. That doesn't really help us. Okay, measures of interior angles of a triangle sum to 180. That is true, but I'm not sure it really helps us with this problem at all. No, it's. I mean, that's a true statement, but that's not really helping us based on side angle side congruency. I have a feeling it's going to be more like, I don't know, let's just keep reading the options. A point on the perpendicular bisector of a line segment is equidistant from the segment's endpoints. That one's looking promising. Let me read the last one. Any line segment is congruent to itself because every point on the segment maps to itself. Again, that's any line segment is congruent to itself because every point on the segment maps to itself. I mean, that's a true statement, but C is the correct answer here. The whole point of having Z is on point L, or on line L, the whole point of that was to show that this is going to be an equal distance. Okay, so if these two triangles that we highlighted in the beginning are equal, then that means that these distances, WZ and YZ, are equal. So this statement, a point on the perpendicular bisector of a line segment is equidistant from the segment's endpoints. There's the endpoints right there, W and Y, and this perfectly describes what we're talking about. And because we know those triangles are congruent, we know that distance is equal also. We got some tough problems so far. These are challenging. All right, so we got NQ and MP intersect at O. This is our last one. Neil noticed that 1 equals, measure of angle 1 equals 180 minus angle 2, and then the same thing for 3, 180 minus measure of angle 2. What theorem can Neil prove using these equations? So the theorem that we have here, using these equations, well, let's take a look. Linear pair angles are complementary. That is false. That one is straight up wrong because we know linear pair angles are not complementary. That means they would add up to, so if we had like A plus B, that would be 90. 90 is complementary, so that one's out. Vertical angles are supplementary. That one's out too. We know vertical angles, so we'll have like A and B, they're congruent. Vertical angles are congruent, not supplementary, so that one's wrong. Linear pair angles are congruent. Okay, linear pair, we already know that's wrong. Vertical angles are congruent. That's true, but let's take a look at this. So why does vertical angles, why is that the only one that works? Well, you see here, if both of these add to the same thing, we're talking about 1 plus 2 and 3 plus 2 equal, well, then that means that these two lines also need to be, or these two angles also need to be equal. Because if they have the same sum this way and the same sum this way, therefore 1 needs to equal 3. And that's what it's trying to show here. There's nothing that you can put here that would make these two different values. So if you did 180 minus 90, no matter what 3 is, 180 minus 90 for 2, it's going to be the same thing. They're going to be 90. Okay, so they have to be equal by definition. Vertical angles are congruent. That's our final answer. So we Had only one problem with the drop-down menus. There's a lot of problems. I've done this Khan Academy several times just to see the types of variety of questions. If there one I didn't get to, I can make a part 2 for you. But again, I hope this was helpful. You can also ask an individual question by typing a comment, and I can help you out there. But either way, I look forward to seeing you next time right here on Wes Explains Best.